So in this video, I am going to prove the law of sine. We know the formula. It's a squared equals b squared plus c squared minus 2bc cos a. But we need to know where did this formula come from, right? So in order to prove it, let us consider a triangle. Say this is A, opposite side is small a, B, small b, small c. Okay? Now, in order to prove it, what we need to do is, let us draw a perpendicular line from here. Okay? Now, what this line did is this split the measurement C into two portions. Okay, let me write it a little bit. So this measurement is C. What this line did is split it into two sections. Let's say these two sections, let's say from here to here, we name it X, and from here to here, we name it Y. Okay, now we also don't know the measurement of the line that we just draw, the perpendicular line. We can name it, let's say M. Okay, now as we have two right angle triangles, we can easily use the trigonometric ratios. Let's consider this right angle triangle. How about if I want to write a relation between X and anything that I know? I can easily say cos of A, right? Cos of A is going to be X divided by B, right? X divided by B. Now, if I want to solve it for X, it should be B times cos A. This is something we should remember. Okay? Why I did it? Because X is something that I don't know, and I need to write it in the form where I know. For example, I know B, okay, I can know the angle A, okay, so this will help me, this expression will help me to get X, okay. Now, let's get into the, let's talk about M. We also don't know M, right? So let's write an expression for M. Using the angle A, I can easily say that sine of angle A will give me the required relation. It will give me M divided by B. Now, if I want to solve it for M, it's going to be B times sine A. Okay? Now, this is the second thing that we needed. Okay? What is the other thing that we added? We added Y. This is something we don't know. We need to write an expression for Y. Okay? Now, Y can be written as C, which is the total length, minus X, right? If I subtract X from C, I will be left with Y, right? So I can write it C minus X. And I already know how much is X. I have it in the normal form, C minus B times cos A. So this is Y. Okay, so I have all the three expressions or measurements X, M, and Y in the form of known measurements. Okay, now let me consider this triangle. Okay, right angle triangle. I can easily use Pythagorean theorem, and Pythagorean theorem will tell me that A squared is equal to the measurement of this side, which is M squared plus Y squared, right? Now, all I need to do is replace M and Y with the form that we already have derived, right? Now, M instead of M, what am I going to write? B sine A. So let's do it. Let's take the square of both. So it's going to be B squared sine square of A. Okay? So M is replaced by M squared is replaced by B squared sine square A. Plus, how about Y squared? Y squared will be replaced by these two expressions. Okay? So we have C minus B cos A. Okay, and here I need to take a square, right? So this is basically this form, right? I can write it, for example, it is a square, sorry, it's a minus b whole square, right? So we know how to write it. It can be written as the first term square plus the second term square minus 2bc, right? Whenever we have two terms and when we have their difference and we want to get the square of it, so this is how we expand it, right? The same way we are going to expand it. So the first term is c, so we are going to have c square. The second term is b cos a, so it's going to be plus b square cos square of a, okay? And the last term is going to be minus 2, the product of both terms. So it's going to be b c cos of a. Okay, now we need to simplify it. What we can notice here is we have b here, b square here, and we have b square here. So they are common, right? So what am I going to do is I can say b square is common and we have sine square a, okay, plus cos square a. Okay, what did I do? I took common b square from here and here, and I wrote sine a square, and I wrote cos square a. Okay, now I'm left with plus c square minus 2bc. Some of you might have already noticed where it is leading, right? Now, we should know from trigonometry that sine square a plus cos square a is equal to 1. Okay? We might prove it in some video, but we should not. Okay? Now, this whole term will give me 1. Okay? So, what am I left with? I am easily left with, let me write it here. I'm easily left with what I need to prove. A square is equal to b square plus c square minus 2bc cos a. So what we did, we just proved the law of cosine. Similarly, we can prove the other sides as well. You see a square plus c square minus 2ac cos b. We can do it. What we need to do is we'll have to take a perpendicular line from some other angle, and for example we do it from here, okay, and then we'll have to deal with this triangle, okay, use Pythagorean theorem on this triangle, and you'll get the same results. Okay, and similarly you can solve the third one. C square equal a square plus b square minus 2bc cos, let me write it, c square equal a square plus b square minus 2ab cos c. You can similarly prove it using the same method. Okay guys, thank you very much for watching, and I hope it is clear.